In the previous video, we're able to talk about the cross product together with the derivation of the formula, its discussion, and a certain example. This time, let's talk about the magnitude of the cross product. The magnitude of the cross product is just similar to the length of the vector corresponding to the cross product of a certain two vectors. So if we're talking about the formula for the cross product, let's say here for vectors x and y, we know that to be x, the cross product with y, is represented by this given components. You have here x sub 2, y sub 3, minus, you have your x sub 3, y sub 2. Then you will have here x sub 3, y sub 1, minus x sub 1, y sub 3. Sorry, that's x sub 1, x sub 1, y sub 3. And you have here, for your last component is x sub 1, y sub 2, minus x sub 2, y sub 1. This will be the components of our cross product for any two vectors. Okay? So we can see here that obviously for the first component, you would not see the first components. Okay? For the second component, you would also not see the second components. And for the third component, you will not see the third components as well. Now, let's talk about the magnitude. The magnitude is simply, again, the length. Okay? So we're talking about the length of the cross product. Simply, it's the square root of the sum of the squares of the components. You have your x sub 2, y sub 3, minus x sub 3, y sub 2 squared. Okay? Plus, you will have your x sub 3, y sub 1, minus x sub 1, y sub 3 squared. Plus, x sub 1, y sub 2, minus x sub 2, y sub 1 squared. Let's illustrate this with the same item that we have presented in the previous video. And of course, you can also review that for the verification of the cross product, because this time let's also show the verification of the cross product before solving for the magnitude. So our x in the previous video, as an example, is with components 1, 0, negative 3, and for your y vector in R3 is actually 2, 4, and negative 1. Again, the cross product was already presented in the previous video, but allow me to also share that here. Okay, so only the components, x sub 2, this will be 0, 0, times y sub 3 is negative 1, minus x sub 3 is negative 3, times your y sub 2, which is 4. Then the second component is x sub 3, that's negative 3, times y sub 1, which is 2, minus x sub 1, which is 1, times y sub 3, negative 1. Then you will have here x sub 1, 1, times y sub 2, which is 4, minus your x sub 2, which is 0, times y sub 1, which is 2. Again, try to verify if my answer is the same as yours and is it the same with the previous video. This is actually 0 minus negative 12. You'll have here minus 6 plus 1, and you have here 4 minus 0, which would give us the cross product of positive 12, 5, negative 5 rather, and 4. This is the cross product of x and y. As for the magnitude, again, similar thing, only solve for, or just solve for the length of the vector. Okay, you can also use the 2 bars there, okay, or use other forms, but this is generally the same. So the square root of the squares, 12 squared, negative 5 squared, 4 squared, their sum. This is actually 144 plus 25 plus 16, which would give us a result of square root of 185. This is now the magnitude of the cross product. It tells us the length or the magnitude of the vector of our cross product identified here. So try to verify this on your own time, and you can also try some other examples as well. Thank you very much for watching.